Good afternoon. Welcome, and thank you for joining us for our session today. We're very excited about the technology that we're going to talk to you guys about today. My name is Yasser El-Hagan. I'm with AWS. I've been with AWS for about 3.5 years. Just a little bit of an overview of what we're going to be talking about today, or just more of the agenda. We're going to start with an Amazon Connect overview. We're then going to have Paul talk to us a little bit about some of our AI services. We're going to go into a live demo, which I'm very excited about sharing with you guys. And then we're going to have Byron Guernsey talk to us about the GE Appliances journey that they've been on, and very excited about that as well. Let's get started. So Amazon Connect, I'm going to talk to you guys a little bit about that. So Amazon strives to be Earth's most customer-centric company. And to do that, everyone who works at Amazon understands that our customers are our top priority, and that our future of our company is built on our customer satisfaction. We have millions of customers that speak dozens of languages, and to service those customers, we have contact centers across 32 countries in the globe. How many people here have ordered something from Amazon? I would expect just about every hand to go up. How many people here have had to actually contact Amazon for some reason? That's actually more than I thought it would be. OK. You might not be aware that we actually have over 70,000 associates that work the contact centers to take care of your needs. And to power that, we actually created our own contact center technology to power those contact centers across the globe. And that's Amazon Connect. And that's what I want to talk to you guys about today. So Amazon Connect is an easy-to-use, cloud-based contact center offering from AWS. It's built to support any business of any size. With tools that grow and shrink as you use them. It's a consumption-based model. It's got skills-based routing with call distribution. Call recording is natively built into Amazon Connect. There's real-time and historical metrics and analytics. And we have a high-quality voice codec that Amazon Connect uses. In fact, some of the recurring feedback we get from our customers as they migrate to Amazon Connect is how much better the audio quality is than their previous system. Some of the differentiators of Amazon Connect, obviously it's a 100% pure cloud-based solution. It's meant to be self-service configurable. And what I mean by that is from the AWS Management Console, where you go find all the other AWS services, you can find Amazon Connect. You click a few buttons, and in about 5 minutes, you have a fully functional contact center stack. One of the powers of Amazon Connect is that it really enables our customers to provide a dynamic, personal, and natural experience for their callers. Let me show you an example.
Hi, Nikki Wolf. I see your flight was canceled today. How can I help you?
Can you please rebook me for the same flight tomorrow?
Okay, you are now booked for a 9 a.m. departure tomorrow out of San Francisco, arriving in Seattle at 11:45 a.m.
Great, thank you.
How many people here have experienced something like this calling into a contact center? That's what I thought. Neither have I, for the most part. So this is really the power of what Amazon Connect provides to our customers. And not just that you can do these things, it's easy to do these things in an iterative process. So what you just noticed here was that we provided a dynamic experience. It was personalized, where we greeted the caller with their name. And it was a natural experience for the caller. They could speak normally into the contact center or the IVR. Some of this experience is powered by things like Lambda. So in the IVR, you can do a real-time data dip to understand more about the caller from their CRM. We can actually go look at other content that we have about our callers, or that you have about your callers. And then we can use that data in real time. So I can greet the caller by their name. Maybe I can see that they've recently opened up a ticket in my support system. So I can start understanding maybe their needs and proactively understand what I might need to do with this experience and dynamically change this experience in real time to provide a personalized experience to the caller. This experience is powered with things like Lambda, Lex, Poly, and some other AI services that we're going to mention today. To really enable that experience, there's something in Amazon Connect called contact flows. And it's really an engine that helps you create experiences for these calls. So it's a processing engine. It's really powerful. Essentially, you could think about it as a UI that allows you to visually understand how you want to treat a contact as it's coming in. Maybe I want to play a prompt. Maybe I want to invoke a Lambda function to get more data or write data. Maybe I want to get things like collect an account number or something like that. I can do that in this visual editor. So it's really powerful from the perspective of, in that IVR, I can invoke a Lambda function, talk to a database, and do things dynamically. Amazon Connect is built on an open platform. And what I mean by that is it can leverage other AWS services, but we also want to make sure that all the data is your data and it's fully accessible to you as a contact center consumer for Amazon Connect. So we have something called a contact control panel, for example. That's our soft phone. So it's WebRTC enabled. You can use Firefox or Chrome. There's nothing to install for the soft phone. But it also has a set of APIs that allows you to embed the soft phone in your CRM or your in-house built application. And you can pass data from that soft phone to that CRM application, and I'm actually going to show you that today. Call recording, like I mentioned, is built into Amazon Connect. It's not something that you have to pay for additionally. And the call recording files are stored in your S3 bucket so that you have full control over the lifecycle policy management, encryption, and it's also an open standards-based recording file, so it's WAV. It's stereo with 2 channels, 1 channel for the customer, 1 channel for the agent, so you can then do some interesting things with transcribe and so forth that we'll talk to you about today as well. There's also an agent event stream that streams data about the agents in real time so that you could do things like integrate with workforce management applications, create custom dashboards. You have full visibility in real time as to when agents are available, if they're taking calls, making calls, and so forth. And metrics. We expose the metrics to you via Kinesis streams, data streams, again, in near real time, that you can then put in your own data warehouse so that you can run your own analytics. And not only are the metrics exposed to you as far as things like who called, when they called, and so forth, but all the metadata and things that you've done in the IVR, so for example, if you went and retrieved data about that call, all that metadata is also added to that record, so you can easily correlate it to other business intelligence data that you might have. And finally, I want to talk to you about the AWS ecosystem that is part of this whole experience. So we have lots of SIs and professional services organizations and partners and third-party integrations. We've had a lot of excitement from our partners around Amazon Connect, and they've built some amazing integrations. They're there to help our customers quickly deploy Amazon Connect. As part of that ecosystem, we also have the depth and breadth of all the other AWS services that can work with Amazon Connect. So these are some of the services that you can use within the contact center. What we want to focus on today, however, is the AI aspect of that. So we have things like Lex, which allows you to build natural conversational interfaces, Poly, which allows you to synthesize text to speech. That sounds very natural. Transcribe, for transcribing the audio into text. And Comprehend, which allows you to understand more out of that text, whether it's key entities, key phrases, and so forth. Today, we're going to focus primarily on Transcribe. And to talk to you about Transcribe, I'm going to ask Paul to come up. He's the product manager for Transcribe. Thank you, Paul.
Thanks, Yasser. Hi, everybody. My name is Paul. I'm the product manager for Amazon Transcribe. Thank you very much for joining us today at our session. Amazon Transcribe is our automatic speech recognition service. It is fully managed and continuously trained, and is powered by deep learning models in the back end. The whole point of Amazon Transcribe is to give you, the developer, a really easy way to integrate speech-to-text capabilities into your applications. We do the heavy lifting. We do all the training in the back end. You don't have to worry about that. At AWS, we like to think about AI and machine learning in 3 layers, right? At the first layer, what you'll see are frameworks. If you have existing workloads, this is the place you want to be playing in. At the second layer is where you might want to be in if you want to build, train, or even host your own models. And of course, at the third layer are what we call the AI services. And again, that's where we do a lot of heavy lifting for you so that you can quickly and easily integrate some of these existing functions and capabilities. Amazon Transcribe belongs to one of many of the language services at this very top layer. Transcribe has a few popular use cases among many. You might be using it to do media subtitling. You might use it to, in this case, transcribe audio from contact centers and then pump it downstream to do real-time text analytics or even batch workload text analytics. For business productivity, you might want to transcribe and capture meeting minutes for later analysis. You might have a court deposition use case whereby you want to have lawyers annotate depositions in real time. Or you might have a video game use case where you want to support users who may have accessibility issues, meaning they might be hearing impaired, but they still want to participate in group chats when they go on fun raids. We've come a long way. Amazon Transcribe was launched in April of 2018. When we first started out, we supported things like punctuation and capitalization, word-level timestamping, word-level confidence scores. We also supported custom vocabularies to help you to be able to recognize specialty words, jargon, technical terminology. And at the time when we first launched, we supported US English and US Spanish. Since then, we've added new features, very exciting new ones, many tackling some of the tough challenges here in the science space with regard to speech. One is speaker identification, and that's exactly as it sounds, being able to identify who is speaking, saying what, and when. We've also added something called channel identification, which is the ability to take multi-channel audio, run transcription on each separate channel, and then produce an output of a single transcript that is coherent and allows you to put that conversation back together. And this is especially pertinent to Amazon Connect. As you can imagine, there's a caller on one channel and there's an agent on another channel, and having this feature is very, very useful. Since then, we've also launched and supported new languages, British English, Australian English, as well as Canadian French. And finally, last Monday, we shipped our brand new feature called streaming transcription. And what that is a real-time transcription capability. Streaming transcription runs over an HTTP2 protocol. You can open a bidirectional stream. You pass to our service an audio stream in real time, and we send back to you a text stream in real time. Here are some of the features of streaming transcription. We support US English today. We also enable custom vocabularies. Of course, we have punctuation, capitalization. At the same time, we allow for multiple concurrent connections, meaning concurrent streams. We also support word-level timestamps, word-level confidence scores, and we support 16-bit linear PCM. We also have this feature that allows you to recognize whether or not we are pumping out text output that is a partial or a full transcript. At this time, I'd like to invite Yasser back for a quick demo. Thank you for your time.
Thanks, Paul. All right, we're actually doing pretty good on time, so let me do this thing here real quick. 1 second. All right. Oop, let's go into presentation mode there. Perfect. Okay, so I have 2 demos that I'd like to share with you guys today. So Paul talked. That's correct. How about that? So Paul talked about transcribe from a perspective of batch jobbing and real time. So I want to show you one of the use cases of what you can do with batch transcription. So one of the things that with Amazon Connect, so I mentioned call recordings that are part of Amazon Connect, and they're placed in your S3 bucket. The way that that really works is that when an agent takes a phone call and call recording is enabled for that contact, as soon as that call is disconnected, the audio recording of that call is put in your S3 bucket. So you can do some interesting things there. You can take that call recording, and since it's in S3, you can trigger a Lambda function that starts this entire flow. And that flow, using step functions, can take that audio recording file and send it through transcribe to be transcribed. With that transcription, I'm going to get a specific transcription for the agent channel and a specific transcription for the customer channel. I can understand what did the customer say and what did the agent say. I can further take that transcription and send it to comprehend, for example, and then get things like, what's the sentiment of what the customer said? Was it positive? Was it mixed? Was it negative? Was it neutral? I can also get the sentiment from an agent perspective. I can get things like key phrases. So what are the key phrases that customers mentioned? What are the key phrases that agents mentioned? I can get things like entities, locations, dates, times, and again, I can split that by customer and agent. I can take the output from comprehend and then send it to Elasticsearch. In Elasticsearch, I can now index it, search it, correlate it, and then I can also use the Kibana built-in dashboard to visualize that data. Amazon Connect also has a Kinesis data stream that pumps out what's called a CTR record. Essentially, it's all the details about that phone call. Who called, what number they called from, what number did they dial, how long were they in the queue, what queue were they in, how many times were they put on hold, all these metrics, including metadata from your business if you did API integrations. So again, I can take these records. All right, there we go. And with Lambda, I can also upsert those records into Elasticsearch. Now, what's really cool about this is I can end up with one document in Elasticsearch that gives me all that detail of who called, when they called, all the things in the CTR. In addition, in that same document, I have the sentiment, the key phrases, the entities broken down by customer and agent. So now I can create some really interesting dashboards, and I'd like to show that to you today. All right. So this is an example of a dashboard that we've created in Kibana. And what you can see here is I can see all the key phrases that were mentioned by customers. Now, this is from a demo system, so it's some interesting key phrases in here. We also have the key phrases from agents. I can also see things like the sentiment per agent or from a customer perspective. And also all that other data that I get out of the call center. Now I can see those things as well in real time. So for example, I can say, OK, show me the details that I have from the last 30 days, and that will update. I can go back 6 months, 90 days, and so forth, depending on the data that I have here. So it's great for real-time analytics. Elasticsearch can be used to store data from the last 30 days, 60 days, 90 days, and you can start dashboarding that information, including things like how many agents are logged in, how many people are on outbound calls, and so forth. What I think is really cool about this is Elasticsearch has APIs that allow you to programmatically interact with it. So now you can do some really interesting things. I have now this one central index of all this data. I can create a Lex chatbot, for example, and embed that in a website that my supervisor uses, and they can ask questions like, how many calls did we get today? I can even enable that via SMS. So all of a sudden, I've unlocked the contact center supervisor from having to be shackled to their desk looking at a dashboard, and they can get some of these details from anywhere. One of the use cases that I really like is with things like, for example, Alexa for Business. I can create an Alexa skill that interacts with this data in real time. For example, let me launch Alexa here on my iPhone. Alexa, ask the contact center how many agents are logged in.
There are 6 agents in the online status.
So you can see this data in real time is coming off of this index. It's really cool. I can say things like, Alexa, ask the contact center how many agents are on the phone.
Looks like there are no agents on the phone right now.
Nobody's making calls. Alexa, ask the contact center how many calls did we get today.
There were 29 calls for November 28, 2018.
So imagine an Alexa device sitting on the supervisor's desk, and they can quickly ask details about their contact center. And you can program these interfaces for whatever's most useful for those contact center supervisors. Completely changes their interactions. So not only can Amazon Connect help your customers have a better experience, your agents have a better experience as well, and I'll show you that in a few minutes, but it also can make a better experience for the actual contact center supervisors and managers as well. All right. the next demo that I'd like to show you. So I mentioned a few things earlier. I talked about how the contact control panel, that soft phone, can be embedded in an application to provide you real-time data or things that you might know about the caller to the agent. So for example, if I know the agent's name from an API call, I can go retrieve that customer's name, sorry. I can greet the customer with their name, but now I can also pass that name to the agent so that they know who's calling and greet them with a personal greeting. So this is the contact control panel. In this example here, I've embedded it into an application that I built just based off of HTML and JavaScript. But for this use case, what we're really excited about is the ability to transcribe the customer audio in real time. So what can I do with this? Lots of applications can be used lots of interesting use cases can be created with this technology. Maybe I want to create some sort of agent assist platform. In this very simplistic example that I'll show you today, I can imagine that instead of an agent sitting there and taking notes throughout a call, what if the notes were automatically taken for the agent, and now they can focus on having a real human interaction with your caller? How much better experience would that be for your customer, right? So that's what I want to show you today. Here we go. So what I'm going to do for this demonstration, imagine that there's an agent sitting here. I'm going to be the customer calling from my phone. I'm going to mute the agent and pretend like I'm talking to an agent, which is going to look kind of funny, but it should be interesting.
Hi, Yasser El-Hagan. Welcome back. Thank you.
Hello there. Yes, I got an email yesterday saying that there was a problem with my order. Can you look into that for me, please? Oh, great. There's not a problem? Perfect. Thank you very much. Bye. So what I've done here is, as I'm having a conversation with the agent can be more focused on having a real interaction and providing a higher level interaction to the customer, while relying on the transcription to be placed in their CRM application, your custom application, or what have you. But there's a lot more you can do with some of the services that Paul talked about. I can apply comprehend on top of this. And now I can understand things like key phrases or entities. So what if I recognize the key phrase like, yeah, I'm calling to check on order number 5237. And I recognize that key phrase, and I can pop that order page automatically for the agent as the next best step, or make recommendations, or even take some of this text and translate it to another language entirely. All sorts of use cases get open with this. And yes, you could do this today by doing a batch job after the call is over, but now I'm really enabling the agent to have a better experience while they can still edit the transcript, for example, and then save it into the CRM. So that's the demonstration for today. All right. So next thing I want to do is I want to bring up Byron, but before we have him come up, sorry. Very excited about having GE Appliances here with us today. A little bit of a backstory. So GE Appliances has actually been an amazing partner with us for Amazon Connect. They were part of our launch in March of 2017 when we launched. In fact, their CTO, Brian Pearson, was on stage with us. And they've fully migrated their contact center platform over to Amazon Connect. And at this point, they're now taking the next step of iteration on top of that. And to tell you all about that is Byron Guernsey. Thank you very much.
Thank you, Yasser.
Yep.
Hello, everyone. My name is Byron Guernsey. I'm the Chief Strategist for GE Appliances. And I'm here to tell you a little bit about what we've done with Amazon Transcribe and using Amazon Connect. So first, let me start by telling you a little bit about GE Appliances. Quite obviously, we make appliances, but you may not know we're located in Louisville, Kentucky, a place better known for its bourbon and the Kentucky Derby than appliances. We employ somewhere on the order of 12,000 people and have been around for 113 years, since 1905. We were part of the larger GE Corporation until 2016, when we were purchased by the Haier Group and merged to become GE Appliances, a Haier company. And as part of that, we came up with a purpose statement that gives our work a purpose and that is enabling happiness and well-being in every home. And I think everybody at the company has a different interpretation of what that means for them. And I've kind of distilled it down into what it is that we do for our consumers. We make time machines. So let me explain that a little bit. Everything we do gives you time back. So when you buy a refrigerator, you don't have to go to the store every day to buy lettuce or beef. It chills it for you. When you have a washer, you no longer have to wash your clothes on a board. You throw them in the washer, it alerts you when they're done. You throw it in the dryer. And in fact, we have connected appliances that use the Amazon platform. Excuse me, I got a bit of a cold here. And so we work in IT, and we need to look at what we can do as IT to save you time at home. So part of that is improving our contact centers. If no one likes to wait, no one likes to be on hold, no one likes to schedule service and have to wait at home and only to reschedule it. So we have, or let me start over, appliances, they can last a long time, but obviously they don't last forever. So eventually everyone is going to call for service. Now we've got service centers or service call centers in the US Midwest and US Southeast. And they handle anything from factory service to consumer relations, parts orders, home delivery for the commercial distribution and sales. And those call centers handle on the order of 7 million minutes a month in about 4 million calls. And a year, that's over 14.4 million consumer contacts that we handle. So I wanted to bring up this quote. It's from Gartner, and it's an analysis showing that 30% of customer service experiences will eventually be handled by automated agents. So that's a target we have for our call deflection. And what that is where a call comes in and you're able to get your answers very quickly talking to an automated agent. And I'll speak a little bit more about that in a minute. But as Yasser said, our CTO, Brian Pearson, was at the Enterprise Connect event, and we had partnered with Amazon on the launch of Connect. We were there in the beta very early, and I'm happy to say now we've moved all of our call centers onto it, and we've been very pleased with the results. So what can we do to improve the call centers? Well, we did an analysis, and we found that we save over $1 million if we improve the first-time resolution of a service visit by only a small percentage. No one wants to have to reschedule because that means we're going to ship you new parts. That means a service technician is going to visit in 3 or 4 days, and you're going to have to take more time off work. To do that, we have to gather the right information when the call comes in. And sometimes that's difficult because the call taker is doing many things at once. The notes that they make don't always indicate what the full problem was. It's a shorthand. And we need to reduce the number of times that you have to repeat your information. There's nothing worse than calling in and giving your phone number or name, and then you're asked a little bit later, could you give your phone number? That should be captured. And the call taker can't always capture all of that information by themselves. Another figure that we calculated was that we would save over $200,000 a year if we increase call deflection by only 1%. And given that Gartner predicts 30% can be achieved, we feel like we've got a lot of savings there still ahead of us. So we put in, to prepare ourselves for this process, we put in this process, which is utilizing Amazon Connect and Transcribe. You'll notice, as Yasser so eloquently said earlier, as a call comes in, it's recorded into a bucket, and that generates an event for us, which we handle with Lambda, and it executes a step function. Currently, that step function, or it used to, we've changed this, it used to split the audio into 2 channels. Because at the time, the speaker diazer that handled a single channel had some difficulties. I think it's improved, but software can only go so far. It's always going to have some errors in prediction. So the new multi-channel deazzer actually identifies the speaker based upon the left channel and right channel. And we've switched over to using that now. We no longer have to split the audio. But what we do after that is take the results from those two channels, merge them back together, and store them in a final JSON format. And we used to have to wait for a while, because what we were doing is utilizing Amazon's AWS Glue to pull the contact record logs from S3 and process them into Redshift. Unfortunately, this was scheduled every 12 hours, so the data wasn't there at the time the WAV file appeared. We would have to wait for 12 hours to be able to pull that data out and populate the JSON file with metadata about the call. And I'll show you what that looks like here in just a second. Another thing we did in this process is extend the JSON format just a little bit by adding in some calculated statistics. Things like the confidence average for the conversation, for the call taker and the caller. The idea being that we can use this information later when we select transcripts that are the best to be able to train machine learning models. And this is some of the metadata that we propagate out of Redshift today. It's information like the contact ID, the customer phone number, the agent username, and all of this is available through Athena, so we can query S3 on any of these fields to be able to pull back calls that have particular attributes. Another change that we made, the original format has the speaker segments identified by a start time and an end time, but we find it much more useful if those are correlated with the actual words. So there's a separate array of words that don't have a speaker label, and as part of this process, we go ahead and propagate that information over, align it, and that way in the future when we're processing the data, it's there available so we can reconstruct the conversation. We also do a CSV transformation of the output, reassembling the conversation into sentences, because the JSON format is just a sequence of words that we receive with timeframes. So it's useful to us to pull that back into a CSV, reconstruct the conversation, and we calculate a few stats about it. That includes words per second and the average confidence for that sentence. And I'll show you how we can use those in just a second. So one of the things that we did with the data, and you'll see it right here, it's a representation of a single day's calls to our help desk, because our help desk, our internal IT help desk, also uses Amazon Connect. And in this scenario, we did a keyphrase analysis and did a word cloud of those phrases. And what we found was that password resets were highlighted for that day. And indeed, that was a day where we had an Active Directory problem that our existing monitoring did not detect, and we actually heard about it from the call centers. Had we this process in place, then we would have been able to identify that it was highlighting that password resets were quickly becoming the dominant trait of those conversations and take action on it. You can automate that as well. Now, the graphs you're seeing here are a graph of the conversation rate of a caller and a call agent. You can see there's a standard deviation, so we can look at that to understand if the call is, the speaker is speeding up through the process of the call, or there's some oddity about that particular call. We can filter these by the standard deviation or the average rate to identify call takers that maybe they're speaking a little too quickly, should slow down, or potentially where there's a problem with an agitated customer who might need more attention. And on these graphs, you can see that we've basically taken a trend line and plotted it of the rate that changes over the course of the call. And you can see there's a coefficient that represents the slope, and should this exceed a certain threshold, we can flag those calls and go back and look to see why the conversation was speeding up. Maybe there's something wrong with that interaction and we need to look at it a little closer. So during the development of this process, there were a few challenges we came up against, and it's been a while. I can say the services have improved vastly. We've given feedback to Amazon, and we've seen that feedback turn around into features very quickly. So the first of those challenges was the fact that initially, as we were loading those logs from Redshift using Glue, we were only doing it every 12 hours. We tried to speed that up to every 30 minutes, and unfortunately, the data was just coming in too quickly. So we're looking at a solution around that, and I'll talk about that in just a minute. We also saw some issues, which I talked about earlier with the speaker deiriser. Amazon has supplied a solution for this. We gave the feedback. They've actually now supported multi-channel audio and identifying the separate channels, which that's solved the problem. It's 100% correct at this point. And we had some issues initially with API soft limits. And this was, this is something to be expected with Amazon. Those limits are in place to protect you, and eventually you run up against them. We didn't expect this at first because we put the process in with a small number of call centers, and gradually over time that grew to the point where we saw errors coming back from the API. And our step function processes would do a retry, but unfortunately over time those would fail as well as the load became too great, and we would get a big backlog of step function failures. And then we also needed to anonymize and scrub the data so that we could provide it to other groups within the organization for analysis. Initially, we looked at Comprehend for this, and at the time, we encountered some issues around identifying proper names, so, like Mike Johnson. We were having trouble identifying every single instance of that, and we went back to a very simple implementation that was based upon a Python library called Scribadub. We built a custom, I think they call it a filter or an analyzer for it, that took a dictionary of 90,000 names and identifies those names in the output. It also does analysis of street addresses, phone numbers, and anonymizes that data as well. So this is the to-be process, what we would like it to look like. We worked with Amazon to come up with this. The differences you'll see is that the events are no longer coming from S3. Instead, we're using the CTR trace records that are generated out of Amazon Connect. We're also using CloudWatch events, and I'll explain how that works a little bit later. But in essence, when we receive the Kinesis event, the contact trace record, we queue a message within SQS, and we spawn off a step function. The step function pulls that message out of SQS and attempts the transcribe call. If for some reason that call fails, it simply leaves the message in SQS and exits. If it's successful, it will then fire a CloudWatch event, which will trigger the Lambda to execute again and release a new step function that will pull another message out. And what this does is allow this model to scale to your available API slots. So initially, I think transcribe has a soft limit of around 10 API slots. If you request it, you can have these increased and work with your Amazon team to do that. And this process will scale up to use all of those available slots. In addition, the fact that it's on SQS, you could have that accessed by multiple accounts and do account-based scaling if you so chose. So I want to go back to this statement that we make time machines. And we have to figure out how to save more time for our consumers. And one of those ways is to utilize machine learning on the transcripts to try to predict what we should do. Our future plans include generating machine learning tasks for natural language processing and natural language understanding to pull out the meaning of those conversations, to be able to do conversation segmentation and classification to identify the segments of the conversation, be it a customer question or an address or the resolution of that call. We'd like to do entity detection and relationship mapping so that we can identify that a particular refrigerator has a model number, or that the refrigerator is making a sound. And then we want to use all of this information to be able to predict what parts it is that we should ship to that customer. Because if we get that right, the service technician shows up, fixes the problem the first time, and everyone's happy. The only way to make them happier is to predict the problem to begin with, and we're working on that as well. And we'd like to move to conversational agent training such that the agents can coach the call takers. You know, suggest that they ask certain questions that they may not have asked. Another case is where they could pull information from the conversation and quickly populate documents that they need during the course of that discussion. What's going on there? Okay. Got it? All right. With that, I'll turn you back over to Yasser. Thank you.
Awesome. Thank you very much. All right. So that's pretty much the presentation that we had. At this point, if we have questions, we can take questions and answers. No questions? Yes. Oh, Byron. So I think the question is, how far off are they on their future plans? The timeline of your future plan.
As soon as possible. We're working on it. I think the answer is we're working on it now with Amazon ProServe. We're starting to have meetings in January around the issue. We've had some ideas on it, but I think Amazon has a group now, a ProServe group that is dedicated to machine learning and will come in and conduct a lab for us.
Yes. Yeah.
I'm curious, are there plans in the works to address, like, how do you recommend getting around that?
Absolutely.
That's something that often gets flagged.
Yeah, so the question is, we showed here how you can use caller ID, for example, to get a caller's identity. In a lot of use cases, that can be very accurate because, as we all know, cell phones are very popular. So most of the callers usually use their cell phone, but there are instances where callers call in from a business line, maybe a shared line, maybe it's a home line where you have multiple callers. We've seen a lot of our customers not necessarily just rely on caller ID. So for example, you can do things, and this is where Lambda becomes really powerful in the IVR flow. So you can say something like, okay, here's the caller ID. You can look it up against your CRM and see if you have multiple records. And then you can do further identification, right? Or if you don't want to use caller ID at all, you can do a Lex chatbot or DTMF input to say something like, please enter your account number or the last 4 digits of your account number, or a combination of the two. Yep. Yes? Yeah, yeah, exactly. So the question was, can you use passive voice identification? And we do have partner integrations that enable that. And that's something that we're looking at, enabling, helping partners enable more of that. But there are partners that enable that today. And that's absolutely a valid use case where you can combine, again, caller ID with voice print or something like that to have a higher level of accuracy or confidence that you've identified the person. Any other questions? Yes. Yeah, great question. So the question was, are there any relational databases being used for the demonstration of Alexa? In that specific demonstration, no. So that actually came directly out of Elasticsearch. And that's why I get excited about that architecture. Elasticsearch is super quick at indexing a large amount of data. And because we have all these documents in Elasticsearch, you can send programmatically a query against Elasticsearch and get back that result in real time. So that's how that was enabled. Yes? The question was, on the live transcription demonstration, is there a limitation on the number of simultaneous streams? There are soft limits in place as part of the service, and you can request for those limits to be increased. Yep. Any other questions? Yes? So the question was, for the Lambda functions that we show that, obviously there's lots of Lambda functions you can use for creating these experiences. Is there a library of them and so forth? There are some Lambda functions that are available on GitHub and other examples like that. There's not a that I know of, but there's been talks from partners and other customers that are looking to enable something like that. From a actual implementation perspective, you can manage that however you manage any other code that you're developing in your infrastructure. Yes? Yeah. There's not any specific plans that I know of, but I know that I've heard lots of conversations from customers and partners about how they want to create something like that, whether it's a user group or a repository on GitHub. But it sounds like you're excited about it, so why don't you start one? Yes? So the question was, he's familiar that we have certain export capability today of contact flows, and are there any plans for being able to export larger configurations that he can just take GE's work and use it in his organization? The answer today is we don't. There's lots of things that we're thinking about for enabling our customers with. We don't talk about roadmap items specifically in these types of sessions, but we can follow up offline. Yeah, so Amazon Transcribe today supports multiple languages for the batch process. For real time today, it's US English. And yeah, our AI services are always looking at adding additional languages, so I would keep an eye out for those. Yes? Yeah, so like I said, we don't speak publicly about roadmap on things like that. The question was around our plans around WFM. There's lots of partners that have WFM integrations today. So if you actually go look on the Amazon Connect website, you'll see available integrations with the most popular WFM platforms today that already exist. We have a lot of our enterprise customers that already have WFM integrations with Amazon Connect. Yep. Yes?
Yes. It is a package called Scrub-a-Dub.
That's an awesome name.
Yeah. Sure.
All right. Any other questions? Yes. Yeah.
Unfortunately, our legal did not want us to talk about the number of agents, so I don't even know that figure. So I can't give it to you. I'm sorry.
There's more than one.
Yeah.
What? Agents. Oh, sorry, go ahead, take that. Oh, yeah, go ahead.
What is GECRM? I believe it's an Oracle package.
What are you saying there? I said you can tell what's greater than 1,000.
It's, gosh, what's the? Oracle Service Cloud. There you go.
Sorry, so we have approval from the CTO right here. Not an exact number, but it's over 1,000 for the number of agents that they've cut over to Amazon Connect. Yep. Any other questions? Yes? In the healthcare space, yes, we do. I can't name a specific customer, but we can follow up offline. Yep. Yes?
Do you support voicemail anytime soon? And then secondly, how many simultaneous calls can an agent handle?
So the question was, do we support voicemail anytime soon, and how many simultaneous calls can an agent handle? So an agent can take one call at a time. So it is a queuing system, just like any call center platform. So obviously you can have multiple calls in a queue, and then as an agent finishes a call, they get another call presented to them. Yeah, they can do outbound as well, yes. Sorry, yeah, so your question really is, can an agent handle multiple contacts from, as far as they're handling a specific contact? So yes, so for example, if you're the customer, you call me, I'm the agent, I can conference in another party, yes. And your question about voicemail, Amazon Connect today does not have a native voicemail functionality. That is something that we're very interested in. You can integrate with external voicemail systems today. Yes? Do you have any virtual hold capability? Absolutely. So the question was, do we have any virtual hold capability? That is natively built into the product. So for example, when I call in, I could say something like, you know, your estimated wait time is going to be 10 minutes. Would you like us to call you back? Right? They select that option, and the system will automatically place that call into a callback state. And once an agent becomes available, the system will then call the agent, the customer back. Yeah, I mean, all those metrics are available to you. For example, you can get really clever with some of these things, right? What I love about Amazon Connect is that as creative as you are, you can usually create most of these experiences. For example, I can do something like, what's the reason for your call today? And I can capture that utterance, right? I can do a callback, and I have this data that I know that I'm expecting a callback in my system for this reason, and I can dashboard that in real time. I can run reports against that and get an understanding of what my callbacks are going to be about, or even present that to the agent as they're getting that callback from the customer. Absolutely. Yes, standing up. So Amazon Connect is PCI compliant. Oh, HIPAA, yes. Amazon Connect, it is, yes. Sorry.
Can you originate calls from a progressive web app or something and do a voice conversation or something?
Yeah, so the question was, can you generate calls, I'll just say externally to the system? So yeah, we do have an API. We have a set of APIs for Amazon Connect. One of the APIs we refer to as the Outbound Api, and you can programmatically generate a call. So for example, you could have something like a web form. Maybe your customers on your website, maybe they're struggling with something on your website. You can put a button that says, you know, click here to call in. The cool thing about that is you can pass these contact attributes as part of that call. So now I know what site they were on, maybe where they were on that site, and I can pass that as metadata to the agent's screen so that they know that this caller was on this page and so forth. And you can obviously use it from an analytics perspective. Absolutely. In the back. So the question was, do you do any type of progress detection on an outbound call? We don't do progress detection today. There are some partner things you could do to make that a little bit better today, but that's not something that's built in natively to the product today. Yes? Yeah, the question was, do you have to open up any firewall ports to make these calls? The answer is it depends. But yes, so it is a very easy, there's a very easy network posture for Amazon Connect. And what I mean by that is that the contact control panel, which is the softphone, it is WebRTC. It's mostly SSL for the agent status, for example. The audio itself is actually destined to, there's one port. So you can, based on that one port, you can open up firewall ports, the firewall port to allow that traffic out. And we also define a specific subnet per region or multiple subnets for the audio. So it makes it very easy for your security folks to build the right rules in place since they know those subnets for a given region and the one port for audio. Absolutely. No, it's I can't remember the port exactly, like 3478 or something like that. That's the destination port on the service. So you can pretty much say any source port to this destination port to this service subnet. allow that traffic, and same thing vice versa. So it makes your firewall rules pretty easy. Yep. Any other questions? Yes? Yeah, sure. So the question is, how do you recommend handling PCI data like credit card transactions and so forth? There's actually, Amazon Connect is actually really good at dealing with this today. In fact, this was one of the use cases one of the first use cases we helped GE Appliances with. So the way that we handle that today is you can do things like, let's say an agent is on the phone with a customer and they need to process a payment or something like that, right? You can actually create a secure IVR within Amazon Connect that the agent can transfer the customer to and transfer all the context, what the order was, how much the payment is for, and all the other details about that transaction, so that when the customer is in the IVR, they can hear a message like, please enter credit card details for the order of a laptop for $800, without the agent really having, now the agent is still kind of held in place so that the customer can come back to that specific agent. So the experience is really good from a customer perspective, but all the credit card details are not going to the agent, they're getting processed in the IVR. And we also have encryption directly within the IVR to encrypt those digits. You can then invoke a Lambda function, which is also PCI compliant, send that credit card details or tokenize it or do whatever you need to do. Once that transaction is complete, I can then send that context back to the agent to let them know that the payment was processed successfully or there was an error or what have you, and have that seamless integration back and forth between the customer, the IVR, and the agent. Yep. If you are not going to the secure IVR, yeah. Just taking the payment, agent is taking the payment, and the recording still be in the same account S3, so the complete account is in PCI scope. So that's a fairly complex question about PCI. We can follow up offline. Sorry. Yep. Any other questions? Nope. All right. Well, thank you guys very much.